So standard and extended ACL we have seen theoretically. Also we did a lab on standard ACL, both numbered and named. Today our focus is on extended ACL. We'll do both numbered as well as named extended ACL. Extended ACL matches 3, sometimes 4. Fourth one is an optional one. At least these 3 should match. What are they? Protocol. Next, the source IP. It can be IP, a single host, or it can be network, source network. And then destination IP or destination network. These 3 are must. Optionally, you can have services. Services like Telnet, SSH, ICMP. See, protocol is IP, TCP, UDP. Okay, this is also a protocol. Then you should not think that why again another word, services. See, in TCP, this is the service. Telnet is a service. SSH is another service. Yeah. So under the protocol, we give the major protocol. And here comes the subcategory in that protocol. And also, if you're blocking OSPF, we are going to block OSPF traffic, then you need to say OSPF here. It won't come in services. If you want to block EIGRP, then you will say EIGRP or RIP. So that is protocol. FTP, Telnet, SSH, HTTP, these are all what? Services. Okay. Now, named ACL, numbered ACL. In extended ACL, numbered ACLs are identified by the number between 100 to 199. This is for extended ACL. What is the number range for standard ACL? 1 to
100.
1 to 100 or 1 to 99? Let us go and check. So let's verify the range. You see, when you go to command prompt and in the global configuration mode, you can easily find it. 1 to 99 and 100 to 199. That's the range. But we will verify that. You see, access list. Good question mark. You see, 1 to 99 is standard access list. So what I have written in for extended access list is wrong. It should be 100 to 199.
Okay, sir.
Standard access list is 1 to 99. Extended is 100 to 199. Okay, so let us now create a scenario. We are going to take like 3 routers and have some servers here. And this server will be called as saif.com. tiva.com, huawei.com. And we'll also have a router. So what I do is I connect all of this through a switch. This is to allow telnet or block telnet. So for telnet testing, I have here telnet, ping, and all. And now this is where from we test. Okay. So this is the IP planning. We'll assign IP address first, and then we'll come and discuss on the scenario. I'm going to take 3 routers, and I'm going to take 3 computers in the left, 3 servers in the right, and 1 router. So this router will be called as demilitarized zone router, DMZ. Packet tracer. I already got 1. I need 2 more. On the servers. When you click on this, you will be able to get servers. I also said we will take 1 router. Alright, let's connect cables now. And some computers for testing in the left. 1, 2, and 3. Alright. So as per the plan, we are going to give IP address.
Sir,
Yes.
are you sharing a screen?
These addresses we will assign first, then we will get into router. We will enable OSPF for reachability. Okay, now let me start from the left. Computers. This is the gateway's address, router's address. See, the IP addresses are given. Let's go to the next computer. Now, moving on to the router side, let's go from the left. We are going from the left, so let's finish this router. Again, this router has got two interfaces. I would like to call this router as router A. Interface G000 10.00.10 interface G001 and as I said, we will enable OSPF router OSPF1 network 10.0.0.0 0.25 Do you remember these things?
Yes, sir.
Okay, I'm putting the entire topology in area 0. Fine. So OSPF is also running. Let us move on to next router 2. I'll call this as router B. Interface G000 IP address is 20.0.0.2. Router OSPF1 networks are 20 and 30. Done. Okay. I'm expecting a neighbor between R1. See, I got a neighbor. This is router A's address. So this is router B. Okay, now router C is still not configured. That's why we don't have a neighbor with router C. We got only one neighbor. You see, show IP OSPF neighbor, only one neighbor, which is 20.0.0.1. Router C now. Okay, I have assigned IP address. Now let us say OSPF. Another network will be 40. So now I'm expecting another OSPF neighbor. For this is the only OSPF neighbor, but for the other router which we saw earlier, that should have now two neighbors. You see, show IP OSPF neighbor. I should see two neighbors because this router RB is in the middle. It has got neighbor with 20001, which is RA, and 400010, which is RC. Now moving on to this router down here. Here I'm not going to assign any routing protocol. I'm not going to configure routing protocol. I'll use a default route. So this is to do testing. So I'll name it as test router. Interface G000. IP route any network, any subnet mask, send it to gateway, which is 400010, the router's address. Okay, so this is also done. On this router, I want to enable telnet service. So I'll create username student1, password pass1, username student2, password pass2, line VTY024, login local, transport input telnet. This is how we enable telnet. So anyone can telnet with this username and password. They will be able to see this router, which is remote to them. Okay, so test router is ready. All right, what is next? We'll configure these servers. Forty zero zero 10. Likewise, the other two servers need to be configured. One more. Done. So all the necessary configuration, the basic configurations are over. So if I try pinging from here, I should be able to ping 10001. See, it's pinging 10002, and 10,003. So these three are extreme left devices in this topology. Here, here, these three. We are able to reach from here to there. Now let us go to this left here and try pinging those servers and the routers. I'm here in this PC. Now I'm going to ping these four devices just to check. 40001. We are able to ping 42. And also I'll ping 3 and 4. Four is the test router. The router should reply now. Yeah, it's replying. Okay. Okay, now what is next? We have reachability end to end, left to right. The other thing I want to show you here is we can design a web page. As I said, this is going to be SAIF. So how to design a web page? Go to services and HTTP. In this index.html, go to edit. And I'm going to say, instead of Cisco packet tracer, I'm going to say SAIF information technology. Welcome to SAIF network. Okay, so this is the web page. Next is I want to check whether I'm able to open this website from these PCs. This is the PC whose address is 10.0.0.1. Now I'll go to this browser here in 10.0.0.1 and type the address of SAIF. What is the address of SAIF? 40.0.0.1. See, 40.0.0.1. See, SAIF Infotech. Welcome to SAIF Network's new opportunity, Mindwide, blah, blah, blah. Now let us do one more website. Tiva. This is going to be Tiva's website. Tiva Information Tech. Welcome to Tiva Tech Park. Say. Done. So let's also create another one for Pavitra's server. Pavitra Infotech. Welcome to Pavitra Networks. Say. So these three websites we are going to access now. Later we'll block one of them, allow the other two, something like that. We are going to test. So let us go to this PC and check we are able to open Tiva's web page, which is 40002. So from this website, this PC left, I'm going to ping the server on the right. Okay. So it is 40002. See, I'm getting Tiva in footing. On the same PC, if I change to 40003, I'll get Pavi in footing, Pavitras in footing, which means things are happening fine. Now from this PC, I'm going to try telnetting to that router. Telnet 40004. You see, it's asking username. I'm going to say student1 pass1. You see, I'm able to see the test router. So far good. We have done all the necessary configuration to have reachability. All that we need to do is we need to block some traffic and test using ACL. It is ready for ACL extended access list testing. Do you have any question?
No, sir.